Hey everyone, welcome back to the Methods 2017 Exam 1, and this video is going to be focusing on question 9c. This question tells us that the edges of the right angle triangle ABC are the line segments AC and BC, which are tangent to the graph of F. Along with these, there's the line segment AB, which is part of the horizontal axis. They let theta be the angle that AC makes with the positive direction of the horizontal axis, and theta is between 45 degrees and 90 degrees, including 45 and not including 90 degrees. Our goal is to find the equation of the line through B and C in the form y equals mx plus c when theta is equal to 45 degrees. Now the first thing we know is that this angle is 45 degrees. The next thing we know is that the line AC and the line BC are perpendicular. This means that when I get the gradient of AC and multiply it by the gradient of BC, this should equal -1. If I rearrange, you'll find that the gradient of BC is -1 divided by the gradient of AC. Now, how do we find the gradient of AC? That's going to be equal to tan theta. And we know theta is equal to 45 degrees. Tan of 45 degrees is just 1. So that means the gradient of BC is -1 divided by 1, which is just -1. So let's construct what we have with our line so far. We know the line BC is equal to -x plus c. We know its gradient is -1, but we don't quite know the y-intercept just yet. So how do I find this y-intercept, which is the last piece of the puzzle? I'm going to let f dash of x equal -1. We know BC, this line, is tangent to F. Since I just need one more point to find C, I can ask the derivative function for what value of x does the slope of the tangent line to the graph of F equal -1. So you'll be able to find the x-coordinate where BC is tangent to F, and then you'll be able to find the y-coordinate, and you can substitute that back into the line. So let's go through with this calculation. We know that the gradient function is 1 minus 3x over 2 root x, and we want this to be equal to -1. Then we get 1 minus 3x is equal to -2 root x. This is a little bit tricky to solve, so I'm going to let a equal root x. Then, from the way I've defined it, we know a squared is going to be equal to square root of x squared, which is just x. So this I can rewrite as 1 minus 3a squared is equal to -2a. Now I'm going to move everything to one side. So we'll get 3a squared minus 2a minus 1 equals 0. Now we're going to need a way to factorize this. And the way we're going to do that is going to be -3a plus a minus 1 equals 0. Then I can factor out this 3a. So you get 3a multiplied by a minus 1. We're just going to take a plus 1 out of this. So it stays a minus 1 equals 0. Then we're going to get this. Now using null factor law, we're going to get a equals 1 or a equals -1/3. Now we know a is equal to square root of x, so we're going to get square root of x equals 1 or square root of x equals -1/3. Now, the positive square root of a number cannot be equal to -1/3, so this solution will be rejected. So we're only going to have square root of x equals 1. Now if I square both sides, that means x has to be equal to 1. This is the x-coordinate for which the tangent to the graph of f has a gradient of -1. Now, we know f of x is equal to square root of x times 1 minus x. So if I find f of 1, that's going to be square root of 1 times 1 minus 1. 1 minus 1 is just 0, so square root of 1 times 0 is just 0. So we know the line BC is actually tangent at this point. So the accurate diagram should maybe look something like that. And we know that it goes through 1, 0. So YBC is equal to negative x plus c. We're going to substitute 1, 0. So the y value is 0 when x is equal to 1. Move the negative 1 to the other side. The y-intercept is 1. Therefore, the equation of the line YBC is going to be equal to negative x plus 1. And this is going to be our final answer. Thanks so much for watching.